All right, welcome back. Cat still alive. Water, not so good. All right, so now we're moving on to A. See, we've got two different A values. Remember, if A is greater than 1, that means it's going to be that vertical stretch. So for this, our f of x, our function that we're looking at, is that greatest integer, which means if I'm going to stretch it vertically, that means my step height is going to get bigger. So our transformation is a vertical stretch because our A was a 2 greater than 1. So by a factor of 2. And for these, I'm going to do one at a time. So I still start at 0, 0. There wasn't an H or a K, so I'm not moving horizontally or vertically. I still start here. I don't have that horizontal stretch or compression, so I'm still extending out 1 unit. But this is where we're going to see that vertical stretch. I'm going to go up 2 units to a closed circle, extend 1 unit, open circle. Up 2 units, closed circle, and so forth. And then we repeat the pattern. Because the only transformation that we're going to see here is that vertical stretch. And then we'll work backwards. So 1, 2. And go at least half the graph. Okay, then over here, it's now 1/2 times our greatest integer function. So since it's between 0 and 1, we have a vertical compression. What that means to us is that our step height, because that's the function we're dealing with, f of x is the greatest integer function, is going to shrink. This is kind of a bummer for this function, not gonna lie, especially when you use fat pens like I'm using. So we're still starting at the origin. I still extend 1 unit, but now I'm going to jump up half and extend out. I'm going to do my best. Probably not the best pen choice, my apologies. But hopefully you can see that I still go close to open, and now my step height from one to the other is a half a unit. I still extend out 1 unit, but the length, how big you have to jump from one to the next, is only a half. Note, use small pens. Okay, the next two we see, notice it's not outside of the function, so it's not going to be that A value. Okay, it's going to be the B value. So what this says is the greatest integer of 2x. Some of you might get into the habit of factoring it out so you can visibly see it. So we have to take the reciprocal of that. So this is going to be a horizontal compression. Batman's rocking if you guys can't see my little superheroes. By a factor, all right, they're not mine, they're my son's, but whatever, of 1/2. Okay, so this means if I'm horizontally compressing for this particular function, we're going to shrink the step. Okay, it's a horizontal compression. So I still start at 0, 0. Oh, Nelly, this is going to be tough, sorry. And then I extend out a half, open circle. I don't have an A value, so I'm going to go up 1 unit, extend out a half. Up 1 unit, extend out a half. Up 1 unit, extend out a half. The only thing that's changing is how far out my step goes. I still go up 1 unit. Notice, yeah, I still go up 1 unit, but I only extend out a half. So go down. Okay, note to self, don't use these pens, sorry guys. Okay, again, go at least halfway through the graph. So then this last one, again, it's a B value. We're going to take the greatest integer of 1/3 times x. Take the reciprocal. That means we have a horizontal stretch. These are way easier to draw and to see. So a horizontal stretch by a factor of 3. Take the reciprocal. All right. So I still start at 0, 0. There's no H, there's no K, but I'm going to extend out 1, 2, 3 units, open circle. There's no A value, so I jump up 1 unit. I'm going to extend 1, 2, 3, open circle. Jump up 1 unit, extend 1, 2, 3, open circle. And then I'm going to work backwards. So 1, 2, 3, close circle, and so forth. These are a little bit easier to draw, so you might want to go a little bit further than normal. All right, part 2 is concluded. I'll see you in part 3.